Hello everyone, this is Chinnaiah Kalpana here. In this video we are going to solve a differential equation using variation of parameters method. So let's get going. Problem. Solve y double dash minus 2y dash minus 3y equal to 64x e power minus x or d square minus 2d minus 3 into y equal to 64x e power minus x using variation of parameters method. So we are given a differential equation of order 2. Given differential equation, y double dash minus 2y dash minus 3y equal to 64x e power minus x. You can write y double dash as d square y by dx square minus 2 into write y dash as dy by dx minus 3y equal to 64x e power minus x, right? Now let's replace dy by dx with differential operator d and y. Or we have d equal to d by dx, then d square will be d square by dx square. Now the equation becomes d square y minus 2dy minus 3y equal to 64x e power minus x. Now take y common from all the three terms of LHS. We'll get d square minus 2d minus 3 into y equal to 64x e power minus x. Consider it as equation 2, which is an operator form. Say f of d into y equal to some function of x. Equation 1 in operator form is our equation 2, right? Where f of d is d square minus 2d minus 3 and r of x is 64x e power minus x. Now, we'll find the general solution to our problem using y equal to yc plus yp, where yc is a complementary function, yp is a particular integral. We'll find yc using the auxiliary equation. Later we'll find yp using yc. Okay, now coming to auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d square minus 2d minus 3, right? Let's replace the differential operator d by m, so that we'll get f of m equal to m square minus 2m minus 3. Then the auxiliary equation becomes m square minus 2m minus 3 equal to 0. Now we need to find roots to this equation, so we'll write minus 2m as minus 3m plus m minus 3 equals to 0. Now take m common from the first two terms, we'll get m times m minus 3. Last two terms remains the same. Now take m minus 3 common from the two terms, we'll get m minus 3 into m plus 1 equal to 0. Now equate each factor to 0. m minus 3 equal to 0, m plus 1 equal to 0. From m minus 3 equal to 0, we'll get m equal to 3, and from m plus 1 equal to 0, we'll get m equal to minus 1. Then m equal to 3 minus 1 are the roots of the auxiliary equation, or m equal to minus 1, 3 are the roots to the auxiliary equation. The roots are real and distinct. We know that when two roots, say m1 and m2, are real and distinct, then yc looks like c1 e power 1 root into x plus c2 e power another root into x, right? Let's now write our complementary function using this. Yc equal to c1 e power 1 root into x. plus c2 e power another root into x. This gives us y is equal to c1 e power minus x plus c2 e power 3x. Therefore, y is equal to c1 e power minus x plus c2 e power 3x is the complementary function to our problem. Now coming to yp, let yp equal to, now replace the constants or parameters with some functions of x, say a and b. We'll get yp equal to a power minus x plus b e power 3x, where a and b are functions of x you can compare yp with au plus bv or yc with c1u plus c2v, so that you'll get u and v, where u is e power minus x and v is e power 3x. See, u is e power minus x and v is e power 3x. And here we are going to find a, b using some formula. A is given by integral minus v into r of x by uv1 minus v1, and b is given by integral u into r of x by uv1 minus v1. If you notice, you are having uv1 minus v1 in both the formulas, so we'll begin with uv1 minus v1 and later we'll find a, b, yp, and finally we'll find general solution using y equal to yc plus yp by substituting yc and yp in it. Here u1 is nothing but derivative of u and v1 is nothing but derivative of v, or you can write u1 as u dash, v1 as v dash. Okay, this is equals to u into v dash minus v into u dash. This gives us e power minus x into derivative of e power 3x using, with respect to x is 3 e power 3x minus e power 3x into derivative of e power minus x with respect to x is minus e power minus x. This gives us 3 e power minus x e power 3x minus into minus plus e power minus x into e power 3x. E power minus x into e power 3x can be written as e power minus x plus 3x, which gives us minus x plus 3x is 2x, right? Now replace e power minus x into e power 3x by e power 2x. You'll get 3 e power 2x plus e power 2x, which is equals to 4 e power 2x, right? Therefore, uv1 minus v1 equal to 4 e power 2x. Now coming to a, is given by integral minus v into r of x by uv1 minus v1. This is equals to minus v e power 3x into r of x, 64 x e power minus x by uv1 minus v1 is 4 e power 2x dx. This is equals to integral minus x e power minus x into e power 3x by e power 2x dx. We know that e power minus x into e power 3x is e power 2x, so we can replace this term with e power 2x. We'll get minus x e power 2x by e power 2x into dx, right? Here we are having 16. This gives us minus 16, e power 2x gets cancelled. Okay, minus 16 integral x dx is x square by 2, which is equals to minus 8 x square. Therefore, a equal to minus 8 x square. We got a, which is minus 8x square. Let's now find b. B is given by integral u r of x by u v1 minus v1 is equals to u e power minus x, r of x is 64, x e power minus x by u v1 minus v1 is 4 e power 2x into dx is equals to integral 16 x e power minus x into e power minus x by e power 2x dx. E power minus x into e power minus x can be written as e power minus x, which gives us e power minus 2x. Now replace e power minus x into e power minus x by e power minus 2x, right? And we can write this fraction or integrand as 16x e power minus 2x into reciprocal of e power 2x into dx, right? This is equals to 16 integral x e power minus 2x into reciprocal of e power 2x is e power minus 2x. We can write e power minus 2x into e power minus 2x as e power minus 2x, which gives us e power minus 4x. Minus 2x is minus 4x. So you'll get e power minus 2x into e power minus 2x equals to e power minus 4x. So let's replace this by e power minus 4x, then we'll get integral e power minus 4x, x e power minus 4x dx, right? Let's now evaluate integral x e power minus 4x separately. So here we are going to apply integration by parts formula. Integral u dv equal to uv minus integral v du. The integrand is of the form product of polynomial function and exponential function, right? We'll consider the polynomial function as u and the remaining part as dv. So we have u equal to x and dv equal to e power minus 4x dx. Now differentiate on both sides with respect to x, which gives us du by dx equal to derivative of x with respect to x is 1. Okay, from this we'll get du equal to dx. Here we'll integrate on both sides to find v. This gives us v equal to integral e power minus 4x dx is e power minus 4x by 4. E power minus 4x by minus 4, or we can just write this as minus e power minus 4x by 4. Let's apply the formula now. Integral u into dv equal to uv, that is x into v, minus e power minus 4x by 4, 4, minus integral v minus e power minus 4x by 4 into du is dx. This gives us minus x e power minus 4x by 4, minus into minus plus 1 by 4 into integral e power minus 4x dx. This gives us minus x e power minus 4x by 4 plus 1 by 4 into integral e power minus 4x dx is e power minus 4x by minus 4, or we can write this as minus x e power minus 4x by 4 plus 1 by 4 into minus e power minus 4x by 4, right? This gives us minus x e power minus 4x by 4 plus into minus minus e power minus 4x by 4 4s are 16. Therefore, integral x e power minus 4x dx equal to minus x e power minus 4x by 4 minus e power minus 4x by 16, right? Since integral x e power minus 4x dx is minus x e power minus 4x by 4 minus e power minus 4x by 16, you can just replace this integral by this result. Okay, now coming to b. This gives us 16 times minus x e power minus 4x by 4 minus e power minus 4x by 16, which gives us minus 16x e power minus 4x by 4 minus 16 e power minus 4x by 16, where 16 gets cancelled. 4 4s are 16, you'll get minus 4x e power minus 4x minus e power minus 4x. Therefore, b equal to minus 4x e power minus 4x minus e power minus 4x. So we got a and b. Let's now find yp using yp equal to a power minus x plus b power 3x. Yp is given by a power minus x plus b e power 3x. Now substitute a and b here. We have a minus 8x square and b is minus 4x e power minus 4x minus e power minus 4x. This gives us minus 8x square e power minus x plus into minus minus 4x e power minus 4x into e power 3x plus into minus minus e power minus 4x e power 3x. See, e power minus 4x into e power 3x is repeating twice. We can write e power minus 4x into e power 3x as e power minus 4x plus 3x, right? This is equals to e power minus 4x plus 3x is minus x. So let's replace this term with e power minus x. Right? Now take e power minus x common from all these three terms. We'll get minus e power minus x times 8x square plus 4x plus 1. Right? Therefore, yp equal to minus e power minus x times 8x square plus 4x plus 1. We got yp and yc also we have. Let's now find the general solution using y equal to yc plus yp. Therefore, the general solution is given by y equal to yc, c1 e power minus x plus c2 e power 3x, and yp is minus e power minus x into 8x square plus 4x plus 1, right? Therefore, y equal to c1 e power minus x plus c2 e power 3x minus e power minus x into 8x square plus 4x plus 1 is the required solution. So this is all for now. I hope you'll understand. We'll see you in the next video. Until then, bye bye.